Hello everybody. Welcome to your second week, second video. So remember our little mini trig unit here is only 3 weeks long. You're doing an awesome job so far. I think it's new for everybody. Video 2B, so this means our second week, and we are into our second concept. This is going to be going towards practice problems number 5 for our con practice sets, which again is just going to be 4 problems. We are still looking at the law of sines, except this time we are going to be taking it into a more contextual situation where we're looking at a triangle instead of just a list of information, which steps up the difficulty a little bit. Although you guys did a great job on the last practice set, I'm just sure of it, so that's nice. Okay, so I'm just going to draw a generic triangle. Remember, triangles are not to scale. I'm just throwing them out here a little bit. So we've got A, B, and C. It would take me forever to draw these for you guys if I were using a protractor. So I'm just eyeballing it. So I've got 37 degrees in that angle. I have 67 degrees in this angle. We know that this side is 10. And we are going to be missing this piece right here. So this time when you're looking at your practice problems today, this is going to be what you are given, which means you're going to have to pull out the pieces of information so that you can use law of sines. So what I can tell is I can see here's my corresponding complete pair. I've got angle C and I also have little c. And here's my incomplete pair, because I've been given angle B, but I am actually missing little b. Now, if you are one of these very spatially minded students, go for it. Set up your law of sines. I need a little bit more. So I'm going to set up my graphic organizer once more so that I can get all of my information somewhere where it makes a little bit more sense to me. But go ahead, be better than me. I appreciate that. So if this is 67 degrees, big B, I know that angle C is 37 degrees. I've already identified that little c is 10, and little b, this is the piece that I'm missing. Now, what you might see in your practice problems is they might ask you for the measure of side AC. That's also what they might ask you for, so be ready for that. Okay, so here's my complete pair as we were looking at in our first practice set this week. Here's my complete pair. I'm going to start with what I don't know, my unknown. So my unknown is going to be side B divided by the sine of B is equal to, now remember we need to keep it the same. If we have sides on top, angles on the bottom, we have to write sides on top, sine of my angle on the bottom. Remember, this is coming from the law of sines, which said sides divided by sine of the angle is equal to side divided by sine of the angle. So this is the easier one, where our unknown is little b, which means we need to undo dividing by sine of 67. So I'm going to multiply both sides by sine of 67. And just in one quick multiplication, now we have little b all by itself, which means it's Desmos time. So I'm going to enter this expression. I've got 10 times the sine funcs, sine 67. Now I'm going to end the parenthesis, I'm going to end another set of parentheses there to make sure I have that entire thing. So there's my numerator. Now I need to divide that by the sine of 37, so back to funks, sine 37, which means that I believe my side B is going to be 15.295478. Okay, so let's go back here. What if little b, this is where I like to throw it back in my organizer, what if little b was 15.295? Does that make sense in my triangle? Smaller angle, bigger angle, which means I need a smaller side, bigger side. So right there I can tell I'm probably right. Let's say that we wanted to round this to the nearest tenth, let's just say, which means I'm looking here. So 15.2, but now I've got a 9. Wow, that's really close to 15.3. So I know that I'm going to round that up to 15.3. Okay, so that's going to be like one of your practice problems today. Your second practice problem is going to be a similar looking triangle, mainly because that's the kind that I enjoy drawing, because I'm a little less than great there. Okay, so let's say we have something like this. That looks awfully equilateral, sorry. Okay, so what if I go with 63 degrees here, and then let's say I've got 13 and 14, and let's call this A, B, C. Okay, so once again, I've got my complete pair. I can see that in my triangle because I have corresponding angles and sides, which means my incomplete pair lies here. So I have this side, but I am missing this angle. So this time you will probably be asked for the measure of angle B. And let's say that we round to the nearest degree, which means we're looking for a whole number there. Okay, so don't mind if I do. ABC, ABC. Doesn't take too long. So I'm going to fill in my complete pair. I know that C is 63, little c is 14. Don't know angle B, but I do know that little b is 13. So here again, I can see my complete pair and what I'm missing. Okay, so for this one, I'm going to start with what I'm missing, what I'm trying to find, which means I've got my signs of my angles in the numerator and my sides in the denominator. So we're going to have one more thing to undo here because we have to undo division, divide by 13, and undo sign. So here's where I'm going to get real lazy. I'm going to undo division by multiplication because we know that the inverse is used to undo. And now I know that the last thing I'm going to have to undo is that sign, which means I'm going to take the inverse sign of all of that stuff. And I'm just going to write it like that. I'm going to give it a little highlight to make sure I don't forget to do that at the end. All right, so now let's see. We know that 14 is bigger than 13, so I'm anticipating that my angle B is going to have to be slightly smaller than 63. Let's see what we end up with. Okay, so I'm going to start on the inside first. Remember, this is just a tip I've learned over the years with using Desmos. So I'm just going to list sine of 63 times 13. Okay. And now I'm going all divided by 14. Okay, I can tell right now that 0.827 is not an appropriate angle measurement. And the reason why it looks so strange is because we forgot to take the inverse sign of it. So at the very end, remember, you're going to tap in front. Make sure your cursor is in front of that expression. And now I'm going to take the inverse sine, there's inverse sine, of that entire thing. So now I'm looking at an angle measurement of 58.82. Now let's think, does that make sense? 13 is a little less than 14, and I can see that an angle of 55 is going to be less than 63. So chances are I did this correctly. So I'm looking for the nearest degree here in my practice problems, which means 55 is going to bump up to 56 because this is 55.8 degrees, which means that that 8 has push power. So that is going to be a 56 degree angle. Okay, kiddos, good luck with this practice problem set. It's been a little while, so let's go back into Khan Academy here. I'll help you out. So I'm going back in. I am in my trig unit. So I'm going into my trigonometry unit. I know I'm looking at law of sines. So we've already been through the beginning, intro to right triangle trig. Now you can see we're in a new section. So the first one is the law of sines. This is going to be today's practice problems. You can see what's coming next. Our last week, we're going to look at cosines and sines. Cosines and story problems, sorry. So I'm looking at law of sines. You guys can see that there are 2 videos that you can watch in case my teaching does nothing for you. There's 2 other resources for you to use. And then I'm going to select the practice problem set. Let's go. And there it is. So you're going to be given your triangle. You're missing the measure of angle B. There's your complete pair. So you're missing an angle. So they started out with one of the tougher ones. If you don't know, you could use a little hint. So again, it's going to send you back to the videos. So take a look. Good luck. We'll see you soon. See what you can do. I miss you guys. Hope you're hanging in there. Bye.